Okay, one of the things that we thought we would address, okay, one is if you perhaps want the help or not. I like the, we scoop an ice cream or, okay, sure, I don't know. Anyway, so one of the things that we look at here, this one, okay, has everyone wrote these down that has decided to want to do that, okay? In case you can't read it, okay? So as a free safety, drops back into coverage. How fast was he moving when changing direction? So the acceleration will change, the velocity changes when things slow down or change directions. And in 2.85 seconds later is at 2.50 meters per second squared. This is important. Why? How do we know this is it doesn't say this is an acceleration. Okay? It's because it says meters per second squared is an acceleration. Because they are then moving at 8.17 meters per second. This is a what? Okay? Not only is it just a velocity, it's a final velocity. Because when you read that, what does it say if it's moving later? That must have meant that there was a speed before that. Does that make sense? Okay. So again, as some of you maybe are either a cornerback or a safety. I don't know if in nine-man football you have a strong safety free. That a lot of that terminology is above and beyond me too. But I just didn't want to write free safety, so that's why I put FS on here. So you've read the question. So if you want to make things easier on yourself, what's the next thing that we think, well, that I don't want to say I, because then I think, oh, this is what you need to do to be successful. But what do you think is the next thing that you perhaps should do? Yeah, write down the information that we know. So we've gone through that verbally. What do we know in this problem? We know the acceleration because it's measured meters per second squared. What else do we know? You correctly said that was your final velocity. Oops. Yeah, I was seeing if anybody was paying attention. I say that a lot though, just because I think people don't want to look foolish in front of other people, and to me, I don't know. I just see if we're paying attention. Yeah. Do we believe that? I wouldn't either. Whoever said no, you're right. Okay. So then what we have left is one more variable, and that is what? Okay. Now, as this is not one of those where you're taking one and trying to solve for another, I thought rather than putting all that information in there, maybe let's just solve for one variable first. Then, if you think you need that extra practice, we can add that on to the end. So, what is this ultimately asking for? So, how fast was he moving when he changed direction? So, that's asking for an initial velocity. All right. So, what formula not only can you use, but what formula do you have to use? The acceleration formula. And in order to do that, how many variables are there in that formula? There are 4, so you have to know at least 3 of them. Okay? So, next thing, do what the formula tells you to do. Okay, so our acceleration, rather than looking up in all this information, we'll look and say, okay, we got that labeled right here. 2.50 equals, so what would go on the right-hand side of our equation? So 8.71 minus VI over 2.85. Okay. Now, we've done this probably how many times? What's the best way to get rid of that fraction on the right side? To cross multiply by putting that 2.50 over 1. So when you do that, okay, does anyone have any questions up to this point? Okay, so what is 1 times 8.71? You get the same number back, 8.71. Okay, so 8.71. What's 1 times negative VI? Negative VI. Okay, so we cross multiplied here. What are we going to do with those two numbers? We're going to cross multiply them in 7.13. Okay, so what is it that we're going to do to get, well, first of all, what order of operations are you doing between this number and that variable? You're subtracting. So can you multiply? No. Can you divide? No, because it's not going to do you any good. So to get this variable all by itself, what would you possibly do to this positive 8.71? If you subtract from both sides, these will cancel. And then what does that do? What does that do to this side when you subtract? So we've got negative VI equals what? Negative, okay? You can divide the whole thing by -1. You can put it in parentheses and take it times -1. Because when you do that, what does it do to these two signs then? It makes them positive. Okay? So sometimes you have to solve for that initial velocity. Okay? So, is there any questions over that? So, let's say, for instance, maybe this free safety, chances are, if they're moving at 1.04, they're probably going backwards like this. This is probably about right, okay? And then maybe having to change directions, and then going in an all-out sprint probably to try to get to that top speed of 8.71, okay? So, let's say, for instance, we wanted to know, maybe he collided with, maybe he made a tackle. If we knew the mass of this free safety, what are two other things that you could solve for, do you think? If you had a mass and you had a final velocity, you can solve for what? You can solve for momentum. If you have a mass and an acceleration, you can solve for what? You can solve for force. Okay. Okay. 1.58, that was his initial velocity then. All right. So, can we erase this? Is there anything else you want to go over with that? Okay. All right. Now, again, we've said this before. How many of you have a really good understanding of this? So for those of you, you can look around. Whoever has their hand up high, if you would ask them, I'm willing to bet they would help you. You can put your hands down now. Okay? And I think, again, the more that you practice this, the better you're going to be at it. Because, for instance, what type of action, if you're shooting free throws, that's a type of what? Probably muscle memory. There are people who are good at free throw shooting. There's others who maybe aren't. It doesn't mean that you're bad at it. It just means sometimes a little extra practice, maybe yes, maybe no. But to me, I think the best way to do this is when you write this information down. It makes it so much easier to see what you have and what you can solve for. for those of you who are really good at this, how many of you think this is a good approach, writing down this information, or you think it's just a waste of time? It's probably a good idea to do that. Okay? Okay, fair enough. So, can I erase this? Well, we're going to anyway, because you can always go back to the science channel and see this information. Okay, this next question, I think for those of you, maybe when you're getting ready for school in the morning, the network, or not network, the local news channels, whether it's KELO, KDLT, or KSFY. There's local news on from approximately 5 a.m. till 7 a.m. because at 7, well then it's the national news that is on the air. And I think this was yesterday morning I saw in Kelloland. I don't know where this was. It was I don't want to say was a beauty shop, but it was places where people would get their hair done. And it showed the surveillance camera that a deer just came plowing right through the front window and just shattered that, and there are people inside. Just think, you're sitting there under a hair dryer, or you're sitting there getting your hair clipped. All of a sudden you just hear something go kaboom, just busting that window right open. Especially if you're sitting right there and didn't see that happening. I know that would probably be kind of frightening. And the funny part about this is, when the deer had to leave, it opened up the door with its horns and went out. It didn't jump out the same window it broke. Maybe he's just felt bad, so he's being polite. I don't know. Felt bad. Let's not break anything else. I don't know if you believe that. It, oh. Oh, there's only 3 people that had phones in this classroom. You know, I was just telling the seniors that exact same thing. I said, man, you people are either more mature, you do what you're told, or you just do the right thing, because I see all the phones in there. I said, well, we do what we're told. That's what the seniors had said. So, and juniors, but, oh, pretty simple. Okay, so you've read this problem, okay? So what is the question asking for? What was the mass? So how big was this deer? Okay, so what's the next thing that you should do? Okay, so what do we know on this problem? Okay, does it matter whether we're saying this is initial final velocity? No, we're just given a velocity because it was moving at this speed when it collided through that window. So once it made that collision, that makes it the final velocity then. 17.30. Okay, what else do we know? Okay, so it wants to know the mass. So, what 2 places do you see that variable m? It's either in the momentum formula or the force formula. Okay? So, in this case, how are we going to solve this then? We got 18.6. Oops. I should have kept going, see if anybody was paying attention. Okay. So what's on the right-hand side then? 17.30 m. So how are we going to get that m or mass all by itself? Divide each side by 17.30. And it should be 105? Okay. Okay. So, which is probably somewhere around 225 pound deer, which probably isn't very big. I don't even know how. I try to judge that by cattle. I mean, it's like a 400-pound steer or heifer is probably about this tall, I would say. If it's about 600 pounds, and then it gets to be somewhere around here, it's probably right around 1,400 pounds. For anyone who's worked with, I don't know, maybe that's accurate, maybe it isn't. Okay, so what about if it was asking for what was the force upon impact? What information would you have to know to solve for that force? Because you've got the mass, you have the acceleration. So what two variables would we need to solve for that acceleration? Which we have, though. Initial velocity and time. Because if you had the initial velocity and the time, you could then solve for the force. But remember, we said we're not putting so many variables in here that maybe we'll just solve for one problem at a time. Okay? Make sense? All right. So sometimes I think maybe some of you would rather write your own type of problem for this. No? Because it's a lot harder than what it looks. Because not only that, but we try to keep this somewhat interesting. I would say go down there right now. Yep. Then head on over. Yep. Okay. So left outside. Are we good? We're on the bus. Left middle. Middle. What's that? Okay. Right middle. Right outside. So if you're nodding your head yes, which everyone was, you're telling me that you're understanding this. So I'm going to hand back some more papers. Then the rest of the time then is yours. Okay. So we will catch up to you next time. Nope, they've been recorded.